Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this June month lecture series, we are discussing about virtual reality in medicine. In Unit 1, we have discussed about 3 I's of virtual reality and 5 classic components of virtual reality and output devices. In output devices part 2, we have graphics displays, sound displays and haptic feedback. Okay, this is our simplified HMD optics model. HMD means you know very well, it is head mounted display. Here, see here the simplified view of HMD optics model. Here we have eye relief distance, focusing distance, virtual image, screen, pixels and the 2 points, focus points A1 and A2. We have optics and exit pupil diameter. We have optical axis from the eye, virtual image pixels we have B1 and B2. Okay, from eye to the virtual image we have eye relief distance, focusing distance, exit pupil diameter, optics, screen and pixels A1, A2. In the opposite side we have virtual image pixels B1 and B2 along with optical axis. Okay. While move on to HMD characteristics, HMD it must be stereo or monoscopic, and we have to discuss about HMD's resolution for particular application of VR and field of view horizontal, field of view vertical, weight and price of HMD. Okay, this is our HMD integration in a VR system. Here we have a monoscopic VR system, stereoscopic VR system. Monoscopic is also called as consumer HMD and our stereoscopic is called as professional HMD. Here both sides we have HMD controllers, HMD tracker control in stereoscopic, but in consumer HMD we have RGB NTSC converter. And while move on to computer system, in consumer HMD we have graphics hardware and view calculation. In computer system we have graphics hardware, left eye as well as right eye calculation and graphics hardware for better vision. And finally we have a tracker receiver in professional HMD and in the monoscopic VR system consumer HMD we have red chart for head adjustment. Okay, this is our example Olympus eye trick face mounted displays. See here how it looks like. The weight of this particular device is 100 grams and it can be worn over glasses. It is normal. It is not normal glass. It is a VR glass which can be worn over our normal glasses, normal specs. Okay, here we have a difference between traditional concave optics versus free shaped prism. Okay, both have LCD displays and in traditional concave we have half mirror only. In Olympus eye trick head mounted displays optics, it uses free form lens to compensate for aberrations. An eccentric optical system to reduce size, eliminate 45-degree mirror. See here Olympus eye trick face mounted display optics. Here we have distance from eye to virtual image and our image in the eye is visualized in virtual world. We can see the virtual world objects through our human eye, but it must be aligned with our optical axis. And we have to perfectly set the diameters and distance from our focus points so that only a perfectly an image or we can feel a real world experience with the help of this HMDs. Okay, next one is our liquid crystal on silicon display. See here the resolution is high when compared to the previous one, but the weight is somewhat high. Normally we have 100 grams, but here it is 160 grams. It can also be worn over glasses. See here, this is a face mounted display. Okay, in this face mounted display we have our eye, lens 1 and lens 2 and polarizer, and LCOS or LCD display. We have optical prism and LED light source for better real world experience, and it is reflective, needs external lighting. And we have OLEDs, organic LEDs. In this OLEDs, active matrix OLED display, each pixel can be addressed independently through the associated TFs and capacitors in the electronic backplane. Here, there are no intrinsic limitations to the pixel count, resolution or size of active matrix OLED display. Here, because of this TFTs in the active matrix design, a defective pixel produces only a dark effect, which is considered to be much less objectionable than a bright point effect like found in LCDs. And in this organic LEDs, we have advantages like a robust design, viewing angles, high resolution, electronic paper applications we have, and we have production advantages, and we have video capabilities and hardware content applications through organic LEDs. Here we have an example of 5DT head mounted display. See here, which has high resolution than previous others. And also we have virtual binoculars. In this virtual binoculars includes 3D tracker, zoom button, polarizer, LED illuminator, LCOS panel, beam splitter, polarizer, eyepiece and eye. Actually, the role of this output displays are, it gives a perfect image, perfect real world image into the virtual reality environment. Thank you.